Hi, hi everyone. While most of you may not come back, okay, I just pick up some characteristic places to conduct my lesson. So today is library, school library, okay? There'll be more. Hey, are you here? Let me see. School hall is maybe there may be too much echo there. So I may not do that because a little bit, or maybe most of you are done. No need to think of chemistry lab because you would have it this week. Okay, you have to come back. Oh yes, it's good for you, 張家榮 huh? You go there directly. Thinking, hey, 蔡仲上 are you here? And for don't you know that for Form 3 students, I asked all of the Form 3 students in my class to turn on the camera. Do you know it? Okay, 蔡仲上 are you here? No. 龐家豪莊俊豪陳豪飛張家榮 here 何展鵬 can you manage to come back already? 何展鵬 yeah, and 林家齊 here, yep, and 麥耀南
早晨淺 Sir， 早晨淺 Sir。
係潘樂志、邵俊熙，潘樂志係魚，潘樂志、邵俊熙。
早晨，淺 Sir。
Oh, it's 12. Okay, so you should be there, right? You should have waken up. 黃俊熙、鄭群威 and for the others, 陳子軒、陳龍華 you here? 陳龍華 are you here? All right, 潘子軒 not here? All right, so 蔡仲常 again, are you here? 蔡仲常好。Now, first of all is our SBA section. Some of you may want to take a look on the detail, and I would like to double check if your lab technicians can also arrange the organic chemistry part. Okay, so I would like to have both together, but which means that it's just for a trial for qualitative analysis for inorganic chemistry. But for organic chemistry, I still hope we can have it simply because for some of the chemical tests, you should know it from the book, but you haven't tried it. For example, tolerance reagents, 2,4-DMP, okay, etc. So this is what I would like to share with you, and you guys, at least you try to figure out how to do experiments and what is that so-called positive results, okay, in reality. So this is what I would like to talk to you about the qualitative analysis. And while on your screen you will see organic chemistry, inorganic chemistry part. So this was once our SBA, and one of the very important SBA. So you're going to deduce the cation anion from two white solid unknown ionic compound. So which means that it is just a simple salt, no double salt, no complex salt. Okay, so what does it mean by double salt? For example, ammonium iron 2 sulfate. Okay, so inside that we have got ammonium and iron 2 ions as cations, two types of cations and one type of anions. So this is what we call it as double salt. Or some of them we call it as complex salt, just like tetramine copper 2 sulfate. So tetramine copper 2 is a complex ion, but we have got another anion sulfate. So for that two types of salt, we will not ask you. Instead, we ask you something easy. So within that combination, okay, within that combination. So take a look on that. It's from potassium, sodium, calcium, ammonium, zinc, lead, and aluminium. For some other cases, we will not be examined. Now, all those other possibilities that will be confined with this. Well, for anion, we have got hydroxide, chloride, bromide, iodide, hydrogen carbonate, and carbonate. You may find that too very tricky. Okay, sulfite, sulfate, thiosulfate. Okay, the final three forms a pair, form a combination, a first change combination, and the observation is rather confusing to you. What you need to do is to have a first hour to come up with the chemicals. What I mean is on the test, and later on, you need to sit down and draw you need to write for your deduction. You were given the following. The amino acid, concentrated one, diluted one. Each one of them will have their own use. Okay, it seems like you go to the wet market. Okay, you buy some. You may get some potato, right? So you may go home and make it as a smashed potato jacket, and etc. Poach. Okay, it's up to you, or even French fries as you like. But the use of that acid is up to you. And we have got some other testing agents, just like chlorine water, sulfur nitrate solution, sodium hydroxide solution, and ammonia solution. You know that the two is very important for you to determine cation, for example, in which it will not give any easily observable flame color. Okay, of course, flame test I will ask you to do so. Okay, you can also try the flame test. It's time to compare theory and practical sense and try to see how difficult it will be. And you may have Ki, calcium nitrate, lactose nitrate. You know what are they? What are the use of they? To test for what? Like barium nitrate. In case you want to have a precipitation reaction, you're looking for that. That are the suitable chemicals. And you may have Scott, the subsolution lime water, KMNO4, K2CO7, hydrogen carbon indicator, phenolphthalein, filter paper, limit paper, pH paper, and some other chemicals. You have to seek my approval beforehand. Okay. And you may turn over to the second page. This is the lab sheet. You need not follow the sequence. Remember, the logical deduction does matter. You are going to give limited time to arrive at the answers as quickly as possible. Okay, so you need not follow that step by step. You have to think of the schematic flow on coming up the deduction, okay? To come up knowing the identity of the cations and anions. So this is somewhat a little bit challenging. And last but not least, after that, you're going to give me your deduction. Okay, in terms of a paragraph length answer. In terms of paragraph length answer. Okay, questions? So this week, we have got the first trial, and the second week, we have got another chance. And most probably next week, you'll be having more chances to try out different types of salts. Questions? I'll give you some time to read through those at home. Any questions? If not, we will come to today's work. So for Chem 1 students, we have finished making the qualitative analysis for organic chemistry part. While for today, for Chem 2 students, we try to have something new, something challenging. Okay, because we are now having an overall revision, right? We have tried out so many different ways to make the revision, and this time we try to try out something new. And I would like to give you a new new file. Yeah. Did you all receive that? Once again, I ask, Choi Jong-sang, are you here? Not here. Absent? Now here we go. You have got a very crazy task today. Follow the mistakes and suggest way to correct the setup. Instead of, you know that Mr. Chin is a very is a guy who loves to spot out the mistakes, right? Especially your mistakes. So the time before you graduate, actually you should know, you should absorb some of my skills such that you can go outside and you'll have an easier life. So I will give you 5. You'll be given to do 5 different examples, and I would like to ask you guys to swallow the mistakes and tell me how to correct them. You know what to do now? This is part 1, and for part 2 here, you'll be more. And the part 2, you maybe need to draw the labels up correctly. Now, very challenging task, right? Okay, you know what to do now? To start with, question 1. I'll just send you a file in the chat box. Do you find it? Do you find the file in the chat box I just sent? No? Maybe I do the same in the WhatsApp group. For those who have received it, could you please type something? Let me know. Zhang Gaowei, have you received it? No, I just sent it on 3 minutes ago. Can convert receive 黃俊浩 receive. Why not you? What background is that? I asked you guys to find out this one. Did you receive it? Did you have it? You view this file. Yeah. So take a look on the first question. Oh, you mean the share screen cannot be seen? But what I just asked you is to whether or not you have received the file. All right. So are you ready? Can I have somebody to answer these questions? Something, hey. First question, what is that setup? What is it called?
Simple distillation.
Simple distillation, yeah. And just follow the mistake.
The thermometer, like the bulb of the thermometer, is a lot lower than the delivery tube.
Okay, so it depends on first of all about to start with the term simple distillation of what is of Z, or maybe to obtain something, right? To obtain pure water, for example. So remember the name simple distillation is just a method, while the chemical should follow, right? You have to tell me the chemical. Same level. Which tools should be in the same level? Somebody who just wrote it at same level. Yep, thermometer bulb and the in a delivery tube. Yes, that's right. That bulb should be here, right? The bulb should be better here. You just lift the bulb of the thermometer and the mouth of the delivery tube. They are just very close to each other. What is the purpose? What is the purpose? Temperature of somebody will write. Of course, thermometer is used to measure the temperature. But what? Measure the temperature of the display. Sorry, no marks. Display, the temperature of display. At where? Now it is also display, right? Boiling point of the vapor. The vapor is a gas form, it cannot be further boiled. Temperature. Oh no, no marks, still no marks. You are going to measure something. Yep, if you say the boiling point, it should be a liquid, right? Boiling point of what? For example, I want to measure the boiling point of this slate, or you want to tell me the condensation point. Right, of those vapor. So each will come to the display. So of course, I would prefer you guys to rewrite that, okay, because it will matches with our purpose. Okay, for the checking whether or not you have collected the distillate. Is the distillate that you want is pure water. Okay. What else? Just one mistakes. 方真浩. Just one? No? Yep, something missing. Yeah. I need to add something. Yep, the term anti-bombing granules. Yes, correct. You have to add the anti-bombing granules in Z, together with Z, while you heat it. My question comes, what is the purpose of adding anti-bombing granules? Smooth what? I can see what smooth. Ensure smooth boiling. What is that? What is that? To prevent water from spilling out during heating. It's not just water, but also some other chemicals, right? And smooth boiling, smooth heating. Boiling is the key, okay? Boiling. That may splash over, right? If no anti-bumping granules has been added, we have got a phenomenon we call it bumping. So what is bumping? What is mean by bumping? Susan, hey, what does it mean by pumping? No. Susan, hey. No, gone away. All right, so Mark Yula, what does it mean by pumping? Yep, sudden burst. So the rapid vaporization of large volume of liquid. And then, so what is the sequence? What is the consequence? It will have you a sudden splashing of solution. Now, because of the accumulation of two large bubbles that come out. So this is the gaseous stage of the product. Okay, so in we will call that a the solution is superheated, right? So finally they will all of a sudden they find some rough surface in order to form a gas bubbles. Okay, so if the solution contains too much heat, while they still cannot vaporize, and they will store the energy, and all of a sudden they would release the energy all of a sudden, and they will form a very large bubbles. While that action, they will have a sudden splashing of the solution. So we will call that bumping. Okay, it is somewhat about while you heat it, and our glass container is made up of Pyrex, and inside that we do not have much rough surface, right, for the solution to boil and form the colorless gas bubbles. So the purpose of adding anti-bumping granules is to provide a rough surface for the vaporization to occur. So once I add to this, they will form some bubbles. Okay, and we will make the so-called boiling smooth, and that is the reason. You understand? Now, two mistakes. One, forgot to anti-bumping granules. Two, is to the measurement of the temperature is to measure the boiling point of distillate, so the bulb of thermometer should be placed higher in the same level as the mouth of the delivery tube. Understand? 展盤要需咧沸騰 is so you are going to boiling with bubbles 麥耀南 of course. Tell me any situation where the solution boils but without bubbles. Help. So it's not just spotting the mistakes, but the way to present your ideas. I will also take a look on that. Yes, it's not. Try to say something logical. Chen Hao, hey, are you here? Yeah. So you love to raise some funny questions, and it's time you have to give me your funny answer. Question 2. Okay. So what is the mistakes? What is that? What is the consequence? Yeah, I know no stopper. Why did we use? Why can't we use stopper here? Yep. Pressure build up and explode. Yes, that's right. So the way to solve is what? Remove it. Okay, remove the stopper. Okay, to release the pressure. Okay, easy. Number 3. Thank you. Giang Huan Wei. Inverted. Should be inverted. Why? It's not just one mistake. Okay, for the others, you may try to spot the other one. Density of CO2 gas is heavier than. You mean higher, right? First of all, if you compare with the density, you use the word higher density than what? Air, not IDK. You spell the word air incorrectly. And so what is that technique? I want to invert it like this. So what is that technique? Downward displacement of air. What does it mean by displacement of air? Air is originally here, and finally they are pushed downward. So downward displacement of air, they refer to this. How about this? But not for this. It's not correct. Somebody would think my task today is too easy. You see that it's too easy to Mr. Chin only in this classroom. Yeah, this one we call it downward displacement of air, or what? So there should be some reason. some meaning of the term instead of just merely memorizing the whole thing. We call it downward what? Is downward the up displacement of air? No, it is upward displacement of air. Can you get my point? So it depends on the gas that may be formed. Now, originally it is air. Air will be expelled and go upward. So we call it upward displacement of air. But if you want to tell that some gases that come out, I know that is CO2, what happened to the gas? The gas will come downward. Can you get my point? So the answer for this part is we call it is downward delivery. Delivery, which means that you use the delivery tube to point downward and let the air go downward. So we call that delivery. But if you want to talk about displacement of air, you are going to think of the direction of air being expelled. Okay? So this downward delivery, upward displacement of air, while the wrong one is what? Downward displacement of air, upward delivery. For those who can make a clear difference between those two terms, please put a thumbs up. Tell me. If not across, if you daydream, just give me a response. Of course, if you daydream, you cannot give me a response. Yeah. All right. So most of you have got it correctly. Now, I would like to give you one more mistake. It's on here, right? How to present it in words. How to present it in words. What should we do? The one end of the delivery tube should be what? For the incoming gas, should be what? Should be immersed. Yes, you use the word immersed into the concentrated sulfuric acid. So, or you don't want to use the word this, you should use the word bubble. Okay, bubble can also be a verb. Bubble. Okay, you should bubble the incoming gas into the concentrated sulfuric acid. Okay, this is remember, if you are having this concentrated sulfuric acid, what is that? It acts as a drying agent. So there are two types of drying agent. Okay, the one is one of them is a liquid one, the other one is solid. For solid one, you need not it's not necessary to so-called immerse or just put it inside the solid drying agent. It's because of the design of the setup. The whole gas, all gas must pass through the drying agent. But for this part, if the drying agent is in liquid state, what will happen? The gas would have a chance to go from here to here without touching the concentrated sulfuric acid. So the drying effect will be much minimized. So the purpose of bubbling the gas inside the liquid drying agent is to let that two meet, okay? Let them two contact, is in contact. So it aims to dry the gas. Can you get my point? So this is what I would like to talk with you about this. If you don't do concentrated sulfuric acid, what other chemicals can be used as a drying agent? Marcus, for this case.
Give me a second, wait.
Are you here? 1, 2, 3. No. Anhydrous calcium chloride. Yes, possible. What else? What else? Now there should be some other cases, right? Just like silica gel. And just like calcium oxide, they are also a drying agent, right? But which one is possible? What is mean by anhydrous copper 2 oxide? What is that? Copper 2 oxide will not have any hydrated form. What is that? I don't know. I don't understand. This one, calcium oxide? Is it possible? Marcus, what do you think? Calcium oxide, is it okay? Hi, Marcus. Gone? Would not be ideal. Why not? You have to justify, right? To see if it is possible, right? Why not?
Okay, the water the water will react with the calcium oxide to form calcium hydroxide and reacts with carbon dioxide.
Oh, the calcium oxide once with mixed with water will form calcium hydroxide, while calcium hydroxide will react with carbon dioxide. That is what Wang Zhenhei has been suggested, is it? What else? Maybe most of you you thought too much about why not thinking as a direct reason. Calcium oxide can react with carbon dioxide directly. What will they form? They will react directly to form, what do you know? Yes, simply calcium carbonate. So you need not think of the moment when lime water is formed or the slag lime will be formed, and then the reaction of between carbon dioxide and the product will react. But the calcium oxide itself would also react with excited gas. Okay, so this is what I would like to remind all of you. So for excited gas, you may use console, silica gel, anhydrous calcium chloride as a drying agent. But for alkaline gas, okay, among them, one of them cannot be used. Do you know which is? It's just like ammonia gas. If the gas is ammonia, right, console is not possible. Also, calcium chloride and anhydrous form is not possible. You know it? Do you understand? That too we know is possible if I use ammonia. So this is somewhat you have to be aware of it. While for the measurement, while the collection of gas, upward or downward delivery or collection underwater, all those, it should be go back to the nature of the gas. So this is somewhat a very important setup that I would like to address to all of you. First of all, now for this type of the graph, you need to separate it into 3 parts. Okay, and very often the mistakes will be found in any one of the parts. The first one is the reaction to produce the gas. Now, please check if that is also possible, right? This one, no mistakes, but you may have a chance of having to consider it to see if there are any mistakes inside. Okay, there's the first part. Second is on here. What is that? Drying of gas. So inside that, you need to consider the choice of the drying agent. Is it possible to use that drying agent? But also, and the mechanical part, whether you have to check whether or not the delivery tube is connected correctly. What I mean is whether or not we have got one part immersed into it, while the other part will not. Now, so for this case, please remember this one, the end of the delivery should be immersed here, but not for this. This one cannot have the delivery tube also immersed, just only one. Okay, which is the for the incoming gas only. Is to what? Is to bubble the gas into the concentrated sulfuric acid so as to maximize the drying effect. You understand? But how about the other end of the derivative? We cannot immerse it as well because if you attempt to do so, the drying agent will leave the derivative instead of the gas. Now, this is somewhat about physics. The final part is on number 3, is the gas collection method. Depending on what, that you need to consider different method. The first of all is the density of the gas. The second is the nature of the gas. While you have the interaction with water, right, you may use different method. Of course, if the gas is set to be dry, you need not consider this. Okay, you simply think of the density of the gas. What to compare is the one with air. And you are going to calculate the RMM of air. You can calculate is about 28.8, while you use the same method to find out the RMM of different gas and try to check against if it is smaller than, roughly similar to, or larger than, in order to determine or not the gas floats or sinks when it meets air. Do you still remember? How about question 4? Now, it is with the written written part. 答案正。How many mistakes are there? Mineral rule is wrong. Now the choice of the mineral rule is correct, but the way for heating is not correct. Okay. So that's why if you read the book, they will say that you are going to heat it strongly here. And then what? You can also make an arrow here. You will see that occasionally. Have you ever seen that? So the purpose of having the heating the mineral occasionally is to vaporize the medicinal paraffin and let the gaseous form passing through the hot catalyst. Okay, that is the point one. Otherwise, no cracking would occur. Okay, can you get my point? They will be directly vaporized. So the consequence is directly vaporized without undergoing what is that process? Cracking. Do you still remember the term? Cracking. Second one. Yeah, that is the first one. Step 3 is something wrong. Stop heating and then remove the delivery tube from water. So how wrong is this? If you do such, they would have a sucking back because of a thermal contraction of the gas. So the inside that is air or maybe some vapor, the product vapor made by the cracking product. So once you remove the heating, what will happen? They will experience the pressure drop inside. So what will happen is to balance the pressure by drawing something inside. So it depends on the end of the delivery tube we should have. If it still touches water, water will come inside the hot glass surface and it will crack the tube. So we will call this phenomenon sucking back of water. Okay, they will crack the tube. Really crack the tube instead of doing the cracking reaction. Okay, this is the first part. And so the way to do that procedure is by do this one and then stop heating. Okay, remove the delivery tube from water first and then stop heating. Lastly, we have got 7 more minutes to go. But for question 5, we have got so many mistakes here. Can you spot them out? There are so many mistakes here. Okay, yes, the bulb of the thermometer is wrong. Second is what? You're going to record the temperature of the vapor which is distilled over. So you are going to have a bulb of the thermometer placed near what? The side arm of the still head. Still head is that T shape. Okay, is that T-shaped one with the still head, the side arm here, right? The junction here, right? So the bulb of thermometer should be put here, number 1. Point number 2, yep, you circle here. What is that? You're going to what? Yep, again, add anti-pumping granules, as said before. So the reason I have just mentioned it, I just skip that. Point number 3, you circle what in, what out. Yes, that's right. So what are the mistakes and what are the consequences if I do it like this? You know that it is quite the opposite, what in here and what out here. So remember, the arrow should go with should match with the direction of water. And this is to enhance the cooling effect of the tube. So what is that? What is that tube called? What is that? It's not what we call it a tube. We call it water condenser. Okay, we call it water condenser. Third mistake. How about next? How about four? Yeah, pressure buildup. Pressure buildup. Never heat in a closed system. Never heat it in closed system. So what was the consequence? The pressure built up. So what should be done? What should be done? I changed this one to a what? It may be a delivery tube adapter, but no need to have a round bottom flask. Okay, you can simply change it to conical flask, etc. Okay, or we've got adapter with a vent. It's also okay. So many possible answers. Point number 4. But indeed, we have got 5 mistakes. What is the 5? What's the 5th mistake? Zhang Gaowing, do you know what is the 5th mistake? Yeah. Somebody circled the solution and put a question mark. Why? Yeah, it's too full. The solution is too full. The flask is too full. So what will happen? Your Form 1 IS teacher taught you so well that you understand. We'll just go into too vague. Too vague. What does mean by we'll just go into the condenser? How? They will spurt out. You better use that term. Okay. The spurt out. Spill. Sorry. Spill also not possible. Not so good. Spill is somewhat means different things. Okay, spurt out. Okay, so this is what you have to know is too full. The flask is too full of solution. Okay, too much. So the solution will spread out when heated. So the way to make it is just 1/3 of a level of the tube is possible. You understand? So here comes the mistakes of those, and you may find that in DSE we often ask you this type of questions. Now go home. Somebody they are still struggling hard. I will not give you the answer, but you yourself have to do so. You are going to draw the label setup of the following. Try to take a look. Altogether, I list you 22 different cases. Take a look. Simple distillation of seawater to obtain sea salt using quick fit apparatus. Using simple apparatus. Filtration. Migration of ions using glassite or U-tube. Carbon reduction of carbon dioxide using crucible with a lid. Reaction with calcium and water to collect hydrogen gas. The reaction of iron with steam to collect hydrogen gas. Setup to show the essential conditions for rusting of iron to occur. Titration setup, for example, ammonia solution against the standard dilute hydrochloric acid using suitable indicator. You use the word against, right? A very technical term. And cracking of paraffin oil. Cracking of paraffin oil 就正往兩件就見。Heating ethane ethanol in a catalyst under reflux. Heated under reflux. Determination of enthalpy change of combustion of an ethanol. Determination of enthalpy change of neutralization of an acid and an alkali. Measuring the rate of formation of carbon dioxide gas in the reaction between calcium carbonate and dilute hydroxide. What else? Measuring the rate of decrease in mass of CO2 gas in the reaction between calcium carbonate and acid. Measuring the rate of reaching certain level of turbidity in the reaction between sodium thiosulfate and dilute sulfur oxide. Fractional distillation of ethanol water mixture. Now, starting from this, here comes paper 2, and you may find some more is on paper 2. Separation of the hexane from hexane water mixture using separating funnel. Suction filtration. Do you still remember what is that? Suction filtration of small crystals of 2,4-dinitrophenohydrazone. Okay. Determination of melting point of a substance or boiling point of a substance. Paper chromatography, thin layer chromatography, and column chromatography. Now, I do hope this time I give you a Word document, and it's time to make a space for yourself, just like this, and you do the remaining parts and treat it as a, it's not just a worksheet, it's a quick revision guide. What do you think? Can you manage to do them all? Yes, that is what you have to do. Okay. Forever zero. How about today? I give you this one. Is it possible to make it as a notes by yourself? And two of you. All those setup they are frequently asked in a DSC. So you better search it out and try to leave some space and draw the own setup and make it as a revision. Do you understand? Okay. I give you as a start. I cannot give you the direct answer. Okay. I want to teach you how to fish instead of giving you a fish, as a Chinese proverb says. Any more questions? Now, if not, it's time to take a break. Remember, next in the coming Thursday, we will see you guys face to face. Okay. See ya. Bye bye.